So when you are working through this problem here, you just take your first term of your divisor and the first term of the dividend, the entire thing that or the entire quotient. And so when you are looking at these first terms here, 2x times what gives you 8x cubed? 4x squared. So I'm going to take that and distribute it to each of these terms. So I get 8x cubed plus 4x squared. I'm then going to subtract, so I'm going to change the sign of both those and combine straight down my columns. So my x cubes cancel. I get a total of 8x squared, and I'm going to drop everything else down. Here I didn't, or in this case you want to write down all the remaining terms that come afterward. And now do the same thing. So 2x times what gives you 8x squared? Same thing. Same thing, 4, but with just 1x. And when I distribute this 4x to both terms here, I get 8x squared plus 4x. Subtract, so I'm going to change the sign and combine straight down my columns. The x squareds now cancel. 10x minus 4x is 6x plus 9. I can still take 2x times what gives me 6x. 3, distribute that through, gives me 6x plus 3. Change the sign, subtract those, and I wind up with a positive 6. Now I can no longer, I'm done. Once the degree of this remaining term is lower than the degree of what I'm dividing by, my divisor, I'm done. That is my remainder. So that's my remainder 6. What I'm left with up here is my quotient, 4x squared plus 4x plus 3. Now, if you were being asked to express the result in this form, what it would be is this entire thing here with the remainder plus 6 over whatever the original divisor is, 2x plus 1, and that's what you would enter as your answer. Okay, so what I want you to do for this last example is see, can you do the same thing when the first term's not a single degree term, but a double or a second degree term? Can you go through and solve the same thing if your divisor is a second degree term?